Hello students, next we are going to look into the topic of fourth module, which is discrete time Fourier analysis. Discrete time Fourier analysis basically has two topics. One is discrete time Fourier series, which is also given in short form as DTFS, discrete time Fourier series, and discrete time Fourier transform, which is the Fourier transform of discrete time signals. So this is what is there in module 4. For you to understand, how we are going in signals and system, basically what you have to see is when we are talking about the continuous time signal, CT signal, and when we are talking about the discrete time signal or DT signal. For both these signals, we have to do the time analysis, we have to do the frequency analysis, and then we have to do the system analysis. So if I am going to look into each of these cases, you will see that for the case of time analysis, that means for the case of continuous time analysis, when we are talking about Fourier series, for continuous time signal, for the case of frequency, we are having continuous time, let me use a different color, we are having continuous time Fourier series, continuous time Fourier series, which is also written as CTFS. This is for periodic signal. This is for periodic signal. Whereas the continuous time Fourier transform or CTFT is for non-periodic. For non-periodic signal. Periodic signal means whose within a period the signal keeps on repeating itself. That is a periodic signal. For example, if you remember, a square wave is basically a periodic signal because this period will keep on repeating. Okay, or a triangular wave is a periodic wave because its period keeps on repeating. Okay. And in the case of continuous time signal, when we are doing the system analysis, we used what is called as the Laplace transform. We use what is called as the Laplace transform. Let me write this in one step down in a different color. We use the Laplace transform. And what happened in Laplace transform was, we basically took the signal which is x of t, or even the system which is h of t, and we converted it, or we transformed it using the Laplace transform into x of s or h of s. And the main reason for doing this was because to make the mathematical portion easy, because once you do the Laplace transform, everything becomes an algebraic equation. Okay. And in the time analysis, basically we study topics like convolution, or the signal operation. We studied signal operations and we studied convolution. Okay, so that is what is basically happening in the time analysis. Signal operations means signal shifting, signal scaling, all those are signal operations. The same thing we did even in DT signal. So here also I will write signal operations and convolution sum. In case of CT signal, it was convolution integral. Now when we are talking about the frequency analysis, just like in case of continuous time signal where we did continuous time Fourier series and continuous time Fourier transform, we are having the discrete time Fourier transform, Fourier series, and discrete time Fourier transform. This is basically for periodic signal. So let me write it using the color that we have chosen here. So we will have discrete time Fourier series. This is for periodic signal. So if you are having a periodic signal, we actually cannot do the discrete time Fourier transform. We do the discrete time Fourier series. And the discrete time Fourier transform is basically being done in the for the case of non-periodic signal. Non-periodic signal. Now you have to understand that these two portions were taken in module 1. These two portions were taken in module 1. Okay. Whereas when we went to module 2, we basically did these two things together. So I will use a different color again. Let me use this color. Okay, these two were done in module 2. In module 3, we did the system analysis as well as the sampling theorem. Now where does sampling theorem come here? Because see, now you have, with the completion of module 1 and module 2, basically you have done everything related to convolution, everything related to continuous time signal. Now what remains is of the discrete time signal. So how will you make a continuous time signal a discrete time signal? You basically use sampling. So when we say sampling, so you have gone from here to a discrete time signal using sampling, okay, which is actually your module 3. So module 3 does not have just this one, but it also has system analysis with respect to the Fourier transform and Laplace transform. Okay, that is what is there in module 3. Now when we are coming here, what is left is this one, which comes in module 4. So let me write that. So this one will come in your module 4. And the last what remains is with respect to system analysis, just like we had Laplace transform, what do we have in discrete time signal? What we have is basically the Z transform. So this is the overview of your of your signals and system, as a subject. So this is module 4. This is module 4 and this is module 5. So what remains now in your signals and system is these two topics, which are actually relatively very simple because there is no integration and all here, only summation related things. So it is relatively simple, and you can see that since this belongs to these two chapters together will almost carry 40% of marks, so it is quite a scoring area. Okay, so this is how in Kerala Technological University the syllabus is being distributed. So you should understand how we are studying the signals and the system for continuous time signal as well as for discrete time signal. Now these two portions will be very much used when you study the next subject of this signal series, which is the digital signal processing. In that case you will have to study these two topics very a little bit more in depth. And tomorrow if you want to make a DSP chip or if you want to design a DSP processor, a thorough understanding of these two modules, module 4 and module 5, is really important. So I would request that you try to attend these these two modules with a lot of care, so that you are able to study these topics in DSP also very easily. Okay, so without wasting any time, I will start with DTFS. So we will start with the discrete time Fourier series, which is also called in short as DTFS. Now the DTFS is basically done for a periodic done for a periodic signal, done for a periodic DT signal. So what do you mean by a periodic signal? See, the definition is, if you are having a signal x of n and you find out a number capital N such that all the values in x of n plus capital N equal to x of n, then it's a periodic signal. For example, if suppose I am going to take a signal, which let me draw it like this, here let me draw it like this, and now I am going to draw the periodic signal. Suppose my periodic signal looks something like this. Now look at this particular signal. Here the first value, let us say it is starting at 0, 1, 2, 3. Now if you would look, this sequence of this much portion of the signal is repeating again and again, isn't? Even if in the back side if you would go, this sequence is basically repeating again and again. So what can I say? I can say that this particular value, that means x of 0, which is this particular value, that is equal to x of 4, correct? And x of 1 is equal to x of 5. Similarly, x of 2 is equal to x of 6, and x of 3 is equal to x of 7. Let us see if that is correct. So if I am going to write the numbers, it is going to be 4, 5, 6, 7, and this keeps on repeating. So what I can say, that if there is any signal x of n, then it is going to be equal to x of n plus 4, and this particular rule keeps on happening for each and every case, isn't it? You can see 2 plus 4 is 6, isn't it? 3 plus 4 is 7, 1 plus 4 is 5, 0 plus 4 is 4. So this particular rule is correct. So what I can say is that this particular signal is periodic with a period of 4, which I will get it from here, the period of 4, and that period we will write it as n, capital N. So I will basically write this is the equation for all n. It is not just for one or two cases, it should be for all values of small n. This rule should follow, then only this will be considered as a periodic signal. Okay, where, you know, one more thing I will show you. See, you can also say that x of 0 is equal to this value, which is 8, which is x of 8. Then x of 1 is equal to x of 9. Like that, this is also true. So I can say that x of n is equal to x of n plus 8, isn't it? So 8, 9, 10. So you can see that this is also correct. Whatever is the value, this much portion is getting repeated again and again. You can say like that also. So yes, this is periodic for 4. It is periodic for 8. It is periodic for 12. It is periodic for any multiples of 4. Any multiples of 4. Out of which the first one, the basic period is 4. So even though you might see that this is periodic for 8, this is periodic for 12 values, but the basic period is 4. So I will say that the fundamental period of the signal, which is n naught, is the smallest value of n possible. Now for such a signal which is having a fundamental period of NO, the discrete Fourier series representation, is given by x of n is equal to summation for k being from 0 to n naught minus 1 decay e raised to power j k omega naught n. I will explain each and every each and every term. Okay, first omega naught. Omega naught is basically 2 pi divided by n naught. Okay, so you might be asking that, you know, what is k then? What is basically k? For understanding that, you have to look at what is the continuous time Fourier series that we have studied. Continuous time Fourier series. Now in continuous time Fourier series, if you would remember, any signal x of t could be represented as a summation of n is equal to minus infinity to infinity, okay, Cn e raised to power jn omega naught t, okay, where omega naught was 2 pi by the time period t of the periodic signal. So this was for continuous time. So what we were doing there, we were taking a signal x of t and trying to find out its Fourier series coefficient c of n. Now this equation is basically what is going for the case of a discrete time Fourier series as this particular equation, wherein now instead of Cn we are having Decay, okay, and instead of making it to go from small t to small n, what we are having here is we are taking the signal x of n, and trying to find out decay. So instead of going from t to n in previous case, we are going from discrete time n to a discrete value k. Okay, so we are basically going from n to k. Okay, now n to k, that means we are going from this point to this point. So n to k. So that's why here when it was n, here you had, instead of that you are having k here. Now this was at a time period t, not time period, this was for the time period which is continuous time. So the continuous time is represented by t, and here it is discrete time which is represented by this small n. So people generally get confused with k and n. They always think that, okay, why is k and why is n? So you should understand that since we are taking a coefficient, we are basically taking a coefficient of, in continuous time we are going from xt to cn. Similarly in discrete time we are going from xn to dk. Okay, so here we had gone from time t to discrete time n. Here we are having discrete time n to discrete value k. So we had gone from discrete time t to discrete value n, and here we are going from discrete time n to discrete value k, and this is something that you should remember. Okay, next omega naught is same as omega naught there, j and all no value, no matter. Another important thing is that you are trying to find out the in continuous time Fourier series, you are taking the values of n which will go from n is equal to minus infinity to infinity, whereas what happens in discrete time Fourier series is that it is periodic signal. Now this is something very important for you to understand, that is if you are having a signal x of t which is periodic, okay, which is periodic x of t, then you are basically trying to find out c of n, which are the Fourier coefficients, which is not periodic. It does not repeat itself, it is not periodic. Whereas if you are going to take a periodic x of n, the Fourier series of that is going to give you dk, but dk, which is the Fourier coefficient in case of discrete time, it is periodic. It is periodic. And what is the period? If the period of x of n, the fundamental period of x of n is n0, then decay is also having a period of n0. Okay, that is why this one is not going from minus infinity to plus infinity, it is going from 0 to n0 minus 1, n0 minus 1. So if n0 is 4, then it will go from 0 to 3. And this is what makes in a way DTFS calculation simple also, because the value becomes very easy to calculate in the case of DTFS. So when CTFS is slightly complicated, DTFS is not that complicated, it is actually quite simple. Okay, now the only thing that remains is how do we find out decay? So how do we find out decay? The equation for decay is given by 1 by the fundamental period n0 summation small n going from 0 to capital N0 minus 1 and taking the signal x of n and multiplying it with e raised to power minus j k omega naught n. That is how you find out decay. Okay, now you might be thinking that, oh, this all looks very complicated. It all looks very complicated. Why should we look at this? This looks very complicated. But actually, it's not very complicated. You will understand that when you do a problem. So remember that x of t, a periodic x of t, a periodic continuous time signal x of t will give Fourier coefficient Cn, which is non-periodic in nature, whereas any periodic discrete time signal x of n will give a Fourier coefficient dk, which is actually periodic in nature with a period of n0. And this thing we should remember. Okay, based on the problem you will be able to understand this x of n and dk much better. Okay, let me write some more things about discrete time Fourier series. Now at k is equal to 0, dk is going to be d0, where d0, okay, where d0 based on this particular equation can be given as 1 by n0 summation n is equal to 0 to n0 minus 1 x of n, no issue, but k is equal to 0, so you are having e raised to power minus j0. And what is e raised to power minus 0? It is basically 1. So it is as good as not writing this because its value is 1. So for d0 it is very simple. You just add up all the xn values within that period and divide it with that period. You will get d0. Okay. So in a way that is the average of the period of the signal. Okay. We will see that as we go forward. Another thing that you should remember is that decay is called as the spectral coefficient of x of n. These are called as the spectral coefficient of x of n. Now based on this we will try to solve a problem and we will try to find out how easy it is to calculate the discrete time Fourier series of a periodic discrete time signal. Hello students. Next let us look at this problem. Determine the Fourier coefficient of the periodic signal x of n as shown in the figure below. Now as you can see, this is a periodic signal because the same period is actually keeping on repeating. That is from 0 to 3 the period is keeping on repeating. I can even visualize this as this particular period, let's say from here to here, this is repeating. Look at this particular values. These four are actually keeping on repeating again and again, isn't it? So one thing that we can say is that in a periodic sequence, if the fundamental period is NO, that NO can start from anywhere, then go up to a length of NO, and then again it will have the next period the same. So NO can have a starting point anywhere. It need not be that it will always start at 0. This is something that you all should remember. Now I will use this concept of discrete time Fourier series to find out the Fourier coefficients of this particular periodic signal. The DTFS of any periodic xn is given by xn can be represented as a summation of dk e raised to power j k omega naught n, where we can find out dk by the equation, where I can find out dk by the equation 1 by n naught summation k is equal to 0 to n naught, and then x of n e raised to power minus j k omega naught n, where omega naught is equal to 2 pi by n naught. Okay, now as I told you, you can start from 0 all the way up to n naught, or you can start from anywhere. So that's why in certain textbooks this summation is sometimes written as summation k is any value within n naught. Okay, not k, here it is n. Yeah, here it is n, sorry. So you can write this for this one, and for this one you can write it for n. Okay, small n. That means basically you need not take it always from 0 to n naught, you can take it from anywhere and that length up to n naught length. Okay, but I'm not going to write it like this, I'm just going to write it like this here. Okay, now let us use this to find out the value of dk. So I will write, so before that let me write the values here. I forgot to write that. This is 1, this is 2, and this is 3. Okay, so therefore I can say, therefore since n naught, here n naught is how much? You can see that the period is from 0 to 3, that means 4 values exactly. So I will write n naught is equal to 4, therefore omega naught is equal to 2 pi by n naught, which is 4, which can be written as pi by 2 radians. Now I am writing this as radians. Okay, I am writing this as radians because it is an omega value. Okay, and we know that pi by 2 is basically 90 degrees. Now why I am saying this is because you have to always remember, I have taught you that how to find out e raised to power some radians. Okay, we'll see that. Therefore now we will start with the values. Before we start, I want to just remind you something, that this value can be written as e raised to power minus j and omega naught the whole raised to power kn. We can write like that. Okay, we can write this particular. Why I am writing like this, you will understand very shortly. So it's very, it becomes very easy if you write something like this, because then if we just need to find out the value of e raised to power minus j omega naught, which is not going to change again and again, it's not going to change, that raised to power kn will actually help us find out the values more easily. So you all know this, that e raised to power a b can be written as e raised to power a raised to power b. Therefore I will be able to write e raised to power minus, therefore e raised to power minus j k omega naught n can be written as e raised to power minus j omega naught the whole raised to power kn, where e raised to power minus j omega naught can be now written as pi by 2, okay, raised to power kn. Okay, now what is e raised to power minus j pi by 2? E raised to power minus j pi by 2. I have always told you that you can write the exponential form as magnitude e raised to power j or j into theta, which is written in polar form as m angle theta. Okay, this is something that we have already seen in many cases. So here also you can write, therefore e raised to power minus j pi by 2 can be written as, the magnitude is 1 here, so 1 angle minus pi by 2. This is in radians. You can write it in degrees as 1 angle minus 90 degree. Okay, 1 angle minus 90 degree. So what happens in that is, this makes the equation very simple for us to calculate. Now what is 1 angle minus 90 degree? You can take the calculator and you can find it out. Otherwise, I have already said that there is one very simple way to do it. Let's draw the polar diagram. So the polar diagram basically has values of real value and imaginary value, which we draw it as j omega. And then if we are going to always have a magnitude of 1. Okay, this magnitude of 1 is always going to be remain as magnitude of 1. So I will draw a magnitude 1 circle. Okay, I will draw a magnitude 1 circle. So let me draw that. So if I draw a magnitude 1 circle, based on the angle, based on the angle I will have different values. For example, this angle is minus 90. So I will draw the value of my vector like this. So this is minus 90 degree. This is minus 90 degree. See, at each and every point here you will have a different value. For example, this will be, a magnitude is 1, so this will be just j. What will be this value? This will be minus j. What will be this value? This will be plus 1 and this will be minus 1. Okay, so whatever be the value that you are having, you can draw. For example, suppose if this is the e raised to power, and suppose this value is some pi by 4. Okay, so you generally write e raised to power j pi by 4. In polar terms we write it as 1 angle pi by 4. In degrees you will write it as pi by 4 is 180 by 4, which is 45. So 1 angle 45 degrees. Okay, and 1 angle 45 degree, if you would try to take the polar format, you will get 0.707 plus j 0.707. That means you are going to get this value as well as this value. So this is going to be 0.707 and this value is going to be plus j 0.707, and that is how we always find out the polar value. If you are getting a simple value like e raised to power minus j pi by 2, then it's better to go directly here, no need to use the calculator. But if you want to use the calculator, you can directly use the calculator. Okay, therefore from here you can see that based on this vector, the value is coming as minus j, just minus j. You can look at the vector here, isn't this? This is minus 90 degree, which comes out to be just minus j value. It is having no real value. You can do the same using calculator. By using the calculator, you can just type 1 angle minus 90 degrees and you will get the value minus 1j or minus j. So it is one and the same thing. So you either you do it using this particular graph, or you use a calculator, that is up to you. Okay, now based on that I can write therefore e raised to power minus j k omega naught n, for our case this particular problem it is going to be minus j raised to power kn, and that will make most of the calculation quite simple. Now I have told that if you are having an n naught of 4 values, if you are having any x of n which is having a periodic value of 4, you find out dk for k ranging from 0 to 3, that means 0 to 3, or you can find out the values of 4 values. That means you will try to find out what is d0, then you will try to find out what is d1, then d2, then d3. You have to just find out these 3 values. So let us write the equation of these 3 values. Okay, therefore now I will start with therefore d0. Now look at the equation. The equation says, this is the equation where this I have already simplified. What remains is this. Okay, so let us write that. So 1 by n naught is 1 by n naught summation k is equal to, is it k or is it n? It is n. So n is equal to 0 to k naught, n naught, x of n, okay, and here k has become 0, okay, for k is equal to 0, that is what I am finding. E raised to power minus j omega naught kn, okay, where that omega naught kn I had basically written as minus j, correct? So minus j raised to power k into n, k is 0, so this is 0, which becomes, what is n naught here? 4. Summation n is equal to 0 to this should be n naught minus 1, sorry, here also I should clear that mistake. This is n naught minus 1, sorry. So it will go from 0 to 3. 3 x of n and minus j raised to power 0 is going to be equal to 1. So I am not going to bother that. Now what is this? 1 by 4 and then x of 0 plus x of 1 plus x of 2 plus x of 3, correct? The 4 values. And what are the 4 values? You can see it is going to be 0, this is going to be 1, this is going to be 2, this is going to be 3. Therefore I will write, therefore d0 is equal to 1 by 4, 0 plus 1 plus 2 plus 3. What are the values that we have got? And this is going to be equal to 6 by 4. Quite simple. Which in its least form can be written as 3 by 2. Okay. Next, for k is equal to 1. For k is equal to 1, therefore d1 is going to be 1 by n naught summation n is equal to 0 to n naught minus 1 x n minus j raised to power kn. Am I correct? Raised to power kn. What is k here? 1. So I can write this as 1 by n naught is going to be 4. Summation is going to be from n is equal to 0 to 3. X of n multiplied with, now here is where the value comes, minus j, k is 1, so it is going to be minus j raised to power n. Okay, minus j raised to power n, which I can write it as, let me write it, 1 by 4. And now I will write 1 by 1. X of 1, x of 0 is 0. So that does not matter. The next is x of 1. So x of 1 is how much? 1. Okay, x of 1 is 1 into minus j raised to power n value is right now 1, plus 2, the next value, x of 2 is equal to 2, correct? X of 2 is equal to 2 into minus j raised to power 2, okay, plus 3, that is x of 4, that is equal to 3 into minus j raised to power 3. Now we know that this will be 0 I am going to leave as such. The next one is going to be minus j, then the next one is 2 into minus j square. Now we know that minus j square will come out to be, minus and minus will become plus, j square will become minus, correct? So this will become minus 2. So instead of writing plus 2, I will write minus 2. Then the last one is plus 3 into minus j cube. So minus j cube can be written as minus j square into minus j, correct? Which minus j square we just now saw, minus j square is coming out to be minus 1 into minus j will become plus j. So I will all have to write is plus 3j, okay, plus 3j. So that value, how much will it come? So the real values, if I am going to take, it is going to be minus 2 by 4, minus 2 by 4, then minus j plus 3j is plus 2j, so plus 2j by 4, where 2 and 4 can get cancelled off. 2 and 4 can get cancelled as 1 by 2, and here also 1 by 2. So I will basically write this as minus 1 by 2, and again 2 by 4 here can be written as plus 1 by 2j. Thus we have found out the value of d1. So d0 we found out, d1 we found out, now d2 and d3 needs to be found out. There is another alternate way. If you don't write minus j, minus j if you don't want to write, don't write. You can use another method also, and that is write what is the original one written, which was e raised to power minus j pi by 2. Okay, that was what was written. So that raised to power, so here if you would see, it was j raised to power 1 minus j raised to power 2. So instead of that, here it will be having minus j e raised to power minus j pi by 2 raised to 1. That is okay. If you come 2, if it becomes 2, then it is as good as e raised to power minus j pi by 2 into 2 will become pi. So originally you can take your calculator and calculate 1 angle minus pi. Remember, you have to do it in radians, or if you are using the calculator in degree mode, you can write it as 1 angle minus 180 degree. Most of the people make this mistake. They forget about what is the mode they are using in the calculator. So if you are using the degree mode, write like this. If you are using the radians mode, you write like this. But using the calculator, you can calculate. Okay, you can directly calculate these values. Let me show that in the previous next case, that is for k is equal to 2. So for k is equal to 2, I will write therefore d2. Okay, so again the equation is 1 by n naught summation k is equal to 0 to n naught minus 1. Okay, n naught minus 1 xn. And now instead of, so I will write e raised to power minus j omega naught raised to power kn. Okay, and this time I am not going to use minus j. Okay, let me use just for you to show how we can do it using a calculator in a simple manner again. So 1 by n naught can be written as 1 by 4. Now summation. So starting from, this is not k, this is n, sorry. So for values from n, so once you are having k is equal to 2, this you can write it as k is equal to 2. So I will write this as raised to power 2n. Okay, so that has become simple. Omega naught is j pi by 2. Let me write it like that, otherwise j pi by 2. Okay, so now what is going to be the value? So 1 by 1, if you multiply pi by 2 raised to power 2n, let me write that step again. So if I write that, then I can write this as 1 by 4 summation n is equal to 0 to 3 xn, and now this has simply become e raised to power minus j pi. 2 and 2 gets cancelled and I get pi n. Okay, so therefore d2 can now be written as 1 by 4 within the brackets x of 0, that I'm taking n is equal to 0, so it becomes e raised to power 0, which is 1. Okay, so no need to write e raised to power 0 is equal to 1. Okay, for the purpose of clarity, I will write e raised to power 0. Next is x of 1 e raised to power, then n is equal to 1 here, so e raised to power minus j pi. Okay, then x of 2 e raised to power, now n has to be 2, so minus j 2 pi. Okay, plus x of 3 e raised to power minus j 3 pi. Okay, now if that is the case, I will again rewrite it as x naught, that is okay, plus x1, which now in our cases, so x naught was 0, so let me take that one out. So 0 will be, x of 0 will be 0, so that I am not going to write. Okay, let me write it as 0 plus x1 is 1, so 1 into, now e raised to power minus j pi can be written as 1 angle minus pi. Okay, plus x2 is how much? 2, and then I can write multiplied with 1 angle how much? Minus 2 pi. Okay, plus x3 is 3 into 1 angle, sorry, 1 angle minus 3 pi. Okay, now either I use a calculator to calculate this, or I can use the the diagram that I had told you, the polar diagram. So this is going to be minus pi, which is going to be minus 1. Okay, then minus 2 pi means all the way coming back here, which is going to be 1. Minus 3 pi is again going to be minus 1. Or you can use the calculator, you can find out that it is going to be 1 by 4, 0 I will leave out, that minus pi is going to be minus 1, so it is going to be 1 into minus 1, which is minus 1, plus 2 into minus 2 pi, this will be 2 into 1, which is 2, plus 3 into minus 1, which is minus 3, which turns out to be minus 4 plus 2, which is minus 2, so minus 2 by 4, which comes to be minus 1 by 2. So this we have found out for K2. Similarly for K is equal to 3, again I will use the same formula. Therefore D3 is equal to 1 by n naught summation n is equal to 0 to n naught minus 1 x of n e raised to power minus j pi by j omega naught kn. K is 3, so 3n. Okay, now I will substitute the values. It is going to be 1 by 4, let me bring it down, 1 by 4 summation n is equal to 0 to 3 xn e raised to power minus j pi by 2. So now that 3 I will take inside, so 3 pi by 2 the whole raised to power n. Okay, so now let me write the values of D3 as 1 by 4. Now the summation x of 0 into e raised to power 0, n value is 0 here, plus then x of 1, then e raised to power minus j3 pi by 2, plus x of 2 e raised to power, if I am going to put 2, then I will get e raised to power minus j3 pi by 2 into 2 is minus j3 pi. The 2 and 2 gets cancelled. Plus x3 e raised to power minus j3 pi by 2 into 3, which is 3 into 3 is 9 pi by 2. Okay, that if you are going to look at the values, you will get 1 by 4, x naught is 0, so the first value I will not write, that is 0, plus the next is x1, which is 1 into e raised to power minus 3 pi by 2 is actually plus j, so 1 into j, you can check that using your calculator, plus x2 is 2 into minus 3 pi, so minus 3 pi will again come as minus 1, you can look at the calculator, and then x3 is 3 into e raised to power minus 9 pi by 2, which will come as minus j, okay, which can be written as 1 by 4, 0 I will take out, j minus 2 minus 3j, and this turns out to be minus 2 by 4, and minus 3j plus j is minus 2j, so minus 2j by 4. Therefore D3 is equal to minus 1 by 2 minus 1 by 2j, minus 1 by 2j. Okay. So we have calculated all the three values of D0, D1, D2, D3. Let me write them together. I will write them together as D0 is 3 by 2, D1 is minus 1 by 2 plus j 1 by 2, D2 is equal to minus 1 by 2, D3 is equal to minus 1 by 2 minus j 1 by 2. So this is all that we have to do. Just find out the values of D0, D1, D2, D3 all the way from k is equal to 0 to k is equal to n naught. So here we are having 4 values which are again and again repeating, so we have to find up to 4 values. If there are 5 values, we have to find 5 values, that means D0, D1, D2, D3, D4. So it is not as difficult as you were doing the Fourier series of a continuous time signal where you had to do all integration. Here it is all summation, so it is quite easy. So if you would look at this problem once again, all you will find out is that it's a simple equation that you have to follow, this one, for finding out the Fourier coefficients. Now this is one of the periodic signals. We will see other periodic signals also. See, one thing that you have to notice is that, see, originally if this would have been a continuous time signal, then this would have been a, if this would have been a continuous time signal, then it would have been a triangle signal. See, it would have been a positive ramp triangle signal, correct? Just like that, any periodic signal that you have studied in continuous time, the same one we will sample it and we will draw it in discrete time, and that discrete time signal we will be trying to find out the Fourier coefficients. And as you can see, the Fourier coefficients is very easy to find. If you just follow simple rule, if you know how to use the calculator, you can very easily find out the values. We will do another problem another day to again look at what are the ideas that we have, like how we can make it more simple. Thank you.